So now that we got our sine, sum, and difference formulas, let's see how we use them. So if I ask you to do the sine in negative pi over 12, this is why I asked what's the common denominator with all of those guys earlier, and we said a 12. Now it may be easier right now for you guys to take negative pi over 12 and convert this into degrees. Cancel, cancel. Negative 18 over 12, or 180 over 12, I guess. Okay, 15 degrees. So you got to figure out some way to get to 15 degrees. Now, the things that we can use are 60s, 45s, and 30s. The nice thing is, these two subtract to 15 degrees, and these two subtract to 15 degrees. It won't matter which ones you pick as long as you get them in the right order. So you can't say, you got to think about if you need a positive or if you need a negative here. So this guy's actually the negative 15 degrees there. So when you're looking at this, you're saying sine of negative 15 degrees. Okay, negative 15 degrees puts you down here. That gives you a negative y value, so our answer better be negative. Now, if we did 60 minus 45, that gives us positive 15. If we did 45 minus 30, that gives us positive 15. So you got to get these things in the right order. So I'm going to pick 30 degrees minus 45 degrees and see what happens. Okay, so the sine formula again tells us to, if we're doing a subtraction, sine first, cosine second, minus cosine first, sine second. So we're going to take this guy, we're going to say sine first, cosine second, minus sine of the second one, cosine of the first one. So if you notice, I actually put these in a different order than the formula, but it won't affect anything because it doesn't matter what order we multiply these. Okay. Now, we need our triangles, and all we got to do is plug in some values. So if we make this a 30, here's your 1, 2, square root of 3. So sine of 30 comes out to 1/2. 45s are always nice because we know those values. 45 again. And cosine of 30 then is square root of 3 over 2. So you should not be repeating both values all the time. Okay, if you have 45s, you will. For other things, you will not. So all we do is you simplify this. Square root of 2 over 4 minus square root of 6 over 4. You actually get the same answer that we did last time. Okay. Now we said our answer should be negative for this. Okay, this guy isn't screaming that it's a negative because it doesn't have something out here. But keep in mind, if you take a square root of 2 minus square root of 6, that gets you to a negative anyway. So if we go back to the original problem and you want to check this in your calculator, you can. If you're going to check it with pi over 12, make sure you're in radians. We converted it to degrees, so I'm still in degrees here. So I'm going to say sine of negative 15 degrees, 0.2588. That's that same answer we got last time. And you can check that again. Square root of 2 minus square root of 6. Divide that whole thing by 4. And there you go. So you'll see a lot of similar answers with these. Okay, there's the books right up doing the exact same thing we did. Just notice they had these guys switched, but it didn't change anything. Or we had those guys switched, but it didn't change anything at all. Okay, last little thing here. You're also going to be tested with going around the circle a couple times, getting to some different quadrants. So we said we're only limited to these guys right here. Okay. Now we can also do multiples of those guys as well. So if you're looking at tangent of 19 pi over 12, here's 12 pi over 12. So here's 24 pi over 12. So that's 2 pi. So here has to be 18 pi over 12. So we got to be something in here. When you put your reference angle in, that guy's going to look like that. So if you want to get to 19 pi over 12, you can. You're just going to have to be adding bigger values. Or you can say, well, if you take 24 pi over 12 and you subtract 19 pi over 12 from it, you're at 5 pi over 12. Obviously, that's a negative because we're going down this way. So maybe the question now becomes tangent of negative 5 pi over 12. You can convert that into degrees and then do a function with that. Okay.